Hello and a really big warm welcome to this presentation from the Urban Penguin. My name is Andrew Mallett and today we're going to take a look at shell scripting. But I don't believe, and I firmly don't believe, that you're going to learn scripting by looking at individual elements. You need to look at scripting as a complete solution. So we're going to start off with a very small script, just displaying information back to the screen, and then look at how we can start prompting or passing information through to the script, building up finally to an application that we can have that is going to allow us to create one or more users dynamically from the command line, making sure all of the parameters that are required to create the user account are set and repeatably correct. We're going to work through our script piece by piece, and you're able to jump in and jump out wherever you need. But to begin with, we're going to look at understanding how we name our script files and what's important about the name. So if you're creating a shell script, should that just have a name? For example, if you're creating a script that is going to create users, should I just call it user_create, or should I call it user_create.bash or .sh? This is the question that we're going to investigate, and the best way to find out is by working at our command line and just taking a look at the difference. So come on, let's go find that glorious command line. And here it is, my Ubuntu 22.04 system. And if we go through and look at our hostname CTL command, we can verify that we are working with Ubuntu 22.04. However, it shouldn't really matter what system that you are working on, but we're going to be looking at working with bash scripting and the bash shell. So that is most important if you need to be able to follow through. But in this clip, we're going to be looking at the importance of the file name. So when we go through and create ourselves a script, how should we call that file name? And we're going to be investigating use of suffixes and without using the suffix. So first of all, let's create ourselves a really basic script. It doesn't matter what text editor you work with. I'm going to be working at the command line to begin with, but later on we're going to be moving into an IDE, a more complex editor, to help us with the complex elements of the script. But if I look at, say, opening up a new file, user_create, in Vim, oops, I don't seem to have Vim on this system, but that doesn't matter. I'll open it in Nano. As I say, the editor at this stage doesn't really matter. If I use Nano and escape and dot, I can bring up the previous argument, so easy put in the user_create file name. Now we might want to create a file just called user_create to try and hide what's going on, so people don't know necessarily that it's a script. But you can see as I start typing, I'm not getting any color coding or syntax highlighting for my file. So it's going to be more difficult to work with as the editor doesn't know what type of file that I am working with. It doesn't know that this is a shell script, and it sees it purely as text that I'm typing. And maybe we want a little bit of help. But anyway, let's go out and save this file. Check that it is working. So I can use bash to open up this file and just run user_create. And we can see then that it is then being opened and interpreted correctly by the bash shell. It's just that the system has no idea of what type of file it is. We can also use the file command and look at the user_create script, and it just comes up as ASCII text. So to the system, there is no idea of what's going on at this stage. So we need to start giving the system a little bit of clue. One way of doing this is perhaps by putting on a suffix, or you might like to call it a extension to the file name. So I might use .bash or .sh. Now when I go through and list it, we can see the file is called user_create.bash. Now that is going to help my editor, but it doesn't help the system. When I still look at this, it doesn't see anything different in the file. The file command still is reporting that this is an ASCII text file. There's no particular header to the text to say what type of file it is. But what will have changed is if I go into my text editor and now open up the file, I'm getting syntax highlighting. I can see the echo and the string are written in different colors. And this is certainly going to help me when I'm editing. But let's add in one more line, a little bit of a header, or what is called the shebang. This then specifies the interpreter that we want to use. Having set that, it won't make any difference to my syntax highlighting, but it will make a difference at the command line when the system interrogates the file. When I use now file and user_create.bash, the addition of the shebang, the interpreter that we want to run the script with, is then being read by our operating system. And in fact, now I can actually rename my file back. So if I call it user_create again, so with no suffix, we've got our plain file. Of course, now using the file command, when I look at the new file name, user_create, without the extension, we can see it's still a bash shell script. But also, the shebang is giving me the syntax highlighting. So using the shebang by itself will act as a guiding light for both the command line and the file command, as well as your editors to be able to determine how the syntax highlighting should be shown. Adding a suffix or an extension to the file name gives you the advantage of visually being able to see what type of file it is just by taking a look at the file name. The downside to this is that it allows users to understand what's going on, and if they see the .sh extension or the .bash extension, just in the same way as it tells you what type of file it is, it's giving your users a clue as to what type of file it is, and they might start digging around and taking a look at it. It does help, though, the suffix does help your editors, telling the editor the syntax highlighting to use. But if we want to obscure the type of file and have help with our editors, then use the shebang. The shebang is the first line of the script and starts with the hash and exclamation mark and then the path to the interpreter. This works both as guiding the editor as to the syntax highlighting to use, as well as telling the operating system and the file command what type of file it is, and you still are able to obscure the type of file from your end users. Having looked at naming our file, we now look at file permissions and the path to where we store the executable. We've seen that we've been able to open up our script so far within the bash command, but you can't really expect your users to prefix the command with bash. They're going to be used to executing programs just by executing the program name. So both permissions and the path, the location of the file, are going to come into understanding in this clip. Here we are again then at our glorious command line, and we've already seen then how we can name our file to help with obscuring the file type, but also in giving information back to the system. So as we've looked, we've got our file user_create. We even have the shebang in the file, the first line, that indicates the interpreter to use. However, we have to use that interpreter. Now, if the idea of calling it user_create was to obscure the type of file it is, it seems very strange then that we have to open it in bash, because after all, it's then giving that information to the users. They have to use the bash command to open up our script. So we've kind of lost the advantage or the high ground that we had over our users in obscuring the file type. Also, our users are going to have to understand where the script is because they have to open the script within bash. So it's not working for us really on any level. We want this to appear far more like any other file just by allowing our users to execute it from any directory on the system. If I try and execute it as user_create, we can see that the command is not found. We might think that's a little bit obscure because we are in the same directory as the file and we know where it is. But in Bash is going to be looking to our path environment variable and searching only those directories. If I use the echo command and look at $path, we can see it's all of these directories that are being searched when I type a command name without putting the actual location of the command as a prefix. All of these directories as well are system directories. Now, eventually, when my script is fully developed, I will probably want it in one of these system directories. But whilst I'm developing it, I will probably create a directory for myself. So in my home directory, I'm creating a directory bin for binaries, not bin for the trash can. But I can move my script into that directory. But that is not going to make the script accessible. The bin directory, my home directory, still needs to be part of my path statement. So I need to adjust the path statement. Typically, you would do that through a login script. But just at the command line here, I can export my current path variable to equal the current path variable that I'm reading in, $path, separate my elements with a colon, and then add in my home directory and then /bin. Now that I've included my own bin directory inside of my path, I can verify that by reading my path variable back, and we can see the last directory to be searched is /home/tux/bin. As I go through now and run the user_create script, still not working. Permission is being denied. But look, we have located the script. Remember before, it was telling me that the script couldn't be found. But we need to add the execute permission, at least for my user account. To change our permissions, we use the chmod or change mode command. The file permissions are known as the file mode, so we're going to use the chmod command. So chmod, I can go through and put A+X. So I'm adding the execute permission to all blocks. That's the user, the group, and others. Ultimately, I want this file to be executable by everyone, so I'm including all 3 blocks, A+X, and then putting through the path to the file name. And of course, that's in my bin directory now. So bin / and then user create. With the execute permission in place, we're going to be able to run our file just by using the file name. And of course, it's going to execute, so we don't have to open it in Bash, and we don't have to worry about putting in the path to the executable. However, if we didn't want to create that extra subdirectory bin and modify our statement, we could then just move into the directory and run /user_create. So we're providing the path through to the executable, so we're no longer using our path variable. But for ease of development, it does make sense creating your own bin directory for scripts that you are developing before they're pushed into production. So adding the execute permission to the file means that we can execute it independently of the bash command, which is going to be really important, and ensuring that the file is located within a directory contained within our path statement means that we don't need to know the location of the script to be able to execute it. It will be searched through the path variable. At the very least, we really want our script to be able to display something other than hello world, maybe hello Bob or hello Sue. So let's look at script arguments and how using script arguments we don't need to hard code values into our script. Now, of course, we can edit and create and manage our scripts from the command line, whether you're using Vim or whether you're using Nano. But as your script starts to grow, you might prefer using a graphical environment and an IDE, an integrated development environment. On this system, I have PyCharm Community Edition installed from JetBrains. It's freely available and available at no cost. There is also a professional edition that allows you to edit systems across SSH. We'll be using the Community Edition, and I can fire this up, and then I can just move across to open up an existing directory, and I can point towards my home directory and the bin directory we created before. I can choose to trust the project. And then, of course, we've opened up the bin directory and we're showing the script that we have inside. Now, PyCharm is really for Python, but it also will work with our bash scripts. Just so we can see it a little easier, I'll just go through and configure the font to be a little larger. But we can see then, just as we did with Nano, we're getting our syntax highlighting. But we'll also be able to demonstrate other benefits that the IDE offers you. Now, at the moment, our script really isn't doing very much. But I can then specify a variable. I can have my user_name, and I can have this hard-coded for the moment to the value of Bob. Now, to use the variable, I can then echo out hello $user_name. For a simple script like this, I can just execute it using the run button, and we can see the terminal then opens, and we get hello Bob coming back. Now, whilst this might seem impressive to begin with, it's not so impressive when you realise that we would have to go in and edit the script to be able to change the output. So if we wanted Bob to appear as Alice, we need to edit the script and change the word Bob to Alice. So yes, it's a good start, but it's not really something I'd want to work with. But if we change the string Alice to the variable $1, this is a special system variable that represents the first argument supplied to the script. To be able to see this working, we're better off just executing it from the command line. I can execute it from the button, but of course there is no parameter or argument supplied. But if I then go through and use .userCreate and then Bob, I get Bob coming out, and then Alice, I'll get hello Alice. So now I've got something that really does, at least on first glance, seem to work. I can also configure the IDE with parameters, but I would have to change those parameters each time the script runs. So it's easy to run from the command line. But look what happens if we use two arguments. We're only referring to $1. Alice is $1, so it prints, but Bob is $2, so it doesn't print. What we can do is process all of our arguments, and this is where an IDE really does work for us. If I type for I, that creates a for loop, so I can then go through and process elements within a list. I want to change my range here and just change it to $, and the @ symbol. This is all of my arguments. And I can then specify for you in $@. So for my username, in all of the usernames that I have supplied, and that's in the variable $@, I then want to go through and process them. So I can set my username variable instead of $1 now. It's going to be $u, the temporary variable that we are using. And now as I go through and execute from the command line, if I use the same script and arguments that I used before, Alice and Bob, I get hello Alice and hello Bob. We've processed both. Going out and then running Alice, Bob, Joe and Frida, we can get all 4 users being greeted. You can see now that you can make your scripts dynamic by using script arguments. $0 would represent the name of the script. $1 would be the first argument supplied to the script. $2 the second argument, and so forth. $hash would be the number of arguments supplied, and $at is a list of all of the arguments. Now, certainly supplying arguments through to our script is really useful and a great addition. But what if arguments aren't supplied? How do we cater for it then? This is where we can take a look at reading user input and making sure that we can cater for those users who want to supply arguments and those users that want to use the application interactively. And here we are. And hopefully you're really gaining some good bash scripting skills. And we're able to see now that we can take our users down a certain path and allow them to provide arguments. But if we don't provide arguments, look what happens. Let me move up to my run button here so I can then run my script. I can see it in the bottom window where we've run bash against my user create script, and we have absolutely no output. I can even test it. Run user create, and we don't even get the hello. Because we haven't provided any arguments, we're not processing elements within the for loop. So this could be both confusing to our users, but also annoying. They might not want to use it from the command line. They might want to use it interactively and provide a username. So we can cater for that, and being able to provide different ways of our users to access the application is going to be useful. So I'm going to go through and we can put an if statement. So literally the word if. We can use the square brackets to create a test condition. And we can look for $hash. If we remember, that was our argument count. And we can specify if it's equal to 0, i.e. we haven't provided any arguments. And make sure when we're using these square brackets that we put a space between the square brackets and any of the content. They're actually treated as commands. So we do need spaces after our commands. And believe it or not, the square bracket is a command. So this is our test where we're testing for there being no arguments. I can end the line with a semicolon and we can put the word then. This saves me having the then on its own separate line. In the if condition, we can use the built-in command read. We can prompt for user input using the option -p to the read command. We can specify an instruction to the user, so enter a username, and typically I would have a colon and a space after this. Now, if I don't specify a variable to use with read, the default name is going to be reply in uppercase, but I'm going to supply the variable user underscore name just so we're sticking to the same variable that we use within our for loop. So we're going to be populating the username variable with whatever input the user puts in. We're then going to echo out our hello and $username. That's the end of the block of code, the code that we need to run if we haven't provided arguments. So we can end that with the else statement, and then I can move my code up. It doesn't need to be indented in, but it makes for better readability by indenting it inside of the else statement, and we would close the if statement with the word fee. Once I'm ready with this, I can go back up to my green button to execute the code. And of course, then we are running it without arguments. So I'm being prompted to enter a username. So I can put in, let's say, Fred, and we get hello Fred coming out. If I go back and let's say execute it with some arguments, so Joe and Sally, we can see then that I get hello Joe and hello Sally coming back. In this way, we can provide flexibility to the user. This is always something that is going to be key in user acceptance, making sure they can use it in different ways and not making the application difficult to use. We're looking at the if statement here and counting the number of arguments. If that is 0, i.e. we haven't provided arguments, we can use the built-in command read to prompt for user input. Else, obviously, then we have provided arguments, we can process the arguments as before. Developing the code further, we're going to start to add functions which are used to encapsulate code and allows repeatability of code. When we create users, the first thing that we're likely to be doing is checking to see if that user exists or not already. But we need to do this in 2 blocks of our code. For the read statement and within our looping structure, processing our arguments. So we want to make sure that we can create a function that encapsulates the check if the user is already there. Come on, let's make sure we can understand the how and the why of using functions. So it seems to me that you are ready for your first function. Do you feel ready? Come on, let's take a look. We don't just want to be displaying information to the screen. We want to eventually be creating users. But before we create the users, we're likely to be checking to see that the user doesn't already exist. But we're going to need to do this in 2 locations. Our first location where we're reading input, and then our second location where we're processing the argument list. So to cater for this, rather than writing the code in 2 places, we can encapsulate the code within a function. So I can just define my function name. I'm going to call it user_exists. We put our parentheses after that, and then our brace brackets. So I'm inside of the brace brackets now. It's the brace brackets that encapsulate my code, the code that we can repeatedly run when we execute the function. Now, the first thing we might want to do is set a variable. And we're setting a variable that will be of scope local. We're going to call it username. I just want to make sure that this is different so it's understandable to be different from the user_name variable that we use outside of the function. I'm going to have it set to the value of $1. Just like a script, a function can take input parameters. So this is the first input parameter. We might find it useful to echo this back to the screen, so at least the user knows that we are processing this user. So we might say something like checking user and then $username. So the first thing that we do is tell the user that we're actually on the case and working on their user. With that done, we then need to start actually checking that the user exists. In Linux, the user is going to be in the etc parsewd file, and we can use grep to search that file. So I'm using my if statement, but I'm using if and then grep. Normally grep will print to the screen when it's found a result. I'm using the option -q to silence the output of grep. And we can look then for the regular expression starting with, so using the uppercase 6 or our caret symbol, so where the line begins with the username followed by a colon. This then is looking at the structure of our passwd file, where the first field is going to be the username and the field delimiters are the colon. And of course then we reference our /etc/passwd file. Now if that succeeds, the user exists. The command itself is going to return a success back to bash. We can check for that, and that is what we're doing with the if statement. So we're saying if this is successful, then the reality is the user exists and we don't want to create the user. So we can go through and specify some text, some feedback to our operator, specifying that the username is already in the system. As we then continue, we've got the else block. So this is where the grep command would fail. If it fails, it's actually a good thing because it's saying that the user account isn't there, so we can proceed to create the user. Now, of course, we're still just displaying information at the moment. We're not actually creating the users, but it's the structure of the script that we need. So we can see now that we are processing our user and being able to display different information based on the user existing or not existing. And as before, the if statement is going to be closed successfully with if spelled backwards. Now, when we look at our main block of code, instead of echoing out the hello username, we can go through and execute our user exists function. And we can go through and specify the $1 input parameter of username. As we say, we need to do this in two locations, though, both for the read block as well as for our processing of our arguments. So again, I can go through and just put in that same line, user exists and $user_name. You can see the sense in making sure that we keep the variables consistent between the read block and our processing of our list, so it makes code management simple for ourselves. We can open up the page a little bit just so we can see the script in full, but now we can go back and try running the script. If we run the script with a couple of arguments, Joe and Sally, we can see checking user Joe, creating user Joe, checking user Sally, and creating user Sally. If we don't provide the argument, we're prompted. I've put in the word Fred, and we can see then we're checking and creating the user Fred. But if the user does exist, let's put in the root user, we can see that Joe and Sally would still be created, but the user root is already in the system, so wouldn't be created. Functions are really important areas of your code. They allow you to encapsulate areas of code that should be repeated perhaps multiple times in your code. But we only have to manage it in the one location inside of the function itself. The next stage of our script takes us into dealing with sensitive data. Now, of course, we're always going to have to consider this, but for us, we perhaps need to set the user's password when we create the user. We certainly don't want to use the passwd command because we're going to be prompted for the password twice, and that's going to be for every user. So if we're creating 3 users, such as in the examples I've used before, we're going to have to type the password 6 times. So that's not going to be convenient, and that's not going to be acceptable to our users or the operators running the script. So what we can look at is prompting for information, but ensuring it's not echoed back to the screen. Now, to start our demonstration, we can actually open up our terminal a little bit. We're going to be able to dive in a little bit of how the read command works. And don't forget, anything that we can type in a script, we can also type at our command line. So using the inbuilt command to bash read, we've already seen that we can use the -p for our prompt, and we can specify then to enter a name. If I don't specify the variable, then it will be stored into the variable reply in uppercase. So we can now see that working by looking at $reply, and we've got the value of Fred. Now, of course, we don't have to use that variable. We can up arrow key back to our read command, and we can add in our own custom variable name. Let's put it in the username here. So now instead of populating the reply variable, we're populating the variable that we set, username. So I can echo out $username, and I get the value that's stored in the variable. But you can see in both instances where we have enter name, we also see the word, the value echoed back. So we're seeing the value of Fred. Now, if we were prompting for a password, this would enable someone perhaps stood behind the operator to be able to see the password that was being set. So obviously this is a bit of a security no-no. So we can add in an additional option, -s for silent, so that we can keep the echo from being sent to the screen. So you can see now that I don't see the name, but if I echo out the variable where we stored that, I'm still having my variable that was populated with the value of Fred. So the silent option becomes really good when we've got sensitive data that we don't want echoed back to the operator's screen. Now, to implement this within our script, we can create ourselves a brand new function. We can call it something like prompt _ password. We're going to use the parentheses again and then our brace brackets to encapsulate our code. And we just need to put in that read statement. So read -s and then p, adding in our prompt. And we can specify the variable to store this in, and we might call it then user _ password. Now this is in a function, and we need the value returned, so we can use echo. This might seem rather strange because we didn't want it echoed to the screen, but you will see how we implement this within our code. So just bear with me until we see how we implement this. I can then echo out the $user _ password, but we'll use that to store in another variable. So we're never going to see our password echoed to the screen. Now we can move down to our user exists, and we can set our password, or at least prompt for the password. And we can populate that with another variable. So new _ password is going to equal the output of prompt password. So prompt password then does print to the screen, but we capture the output and populate the variable new password, so we never have to actually see it. With that done, we can actually see it working and seeing that it is not echoing out the information. So let's move back out, run our script. We're being prompted for the username, but then the password, but obviously we're not seeing the password at the screen, and we don't see the password being printed to the screen. Now, just for the demonstration purposes, if we want to actually look at the password, well, we can still display it. So we can move back into our script, and just for the purposes of actually proving we did capture the password, we can then echo out the value of new password. So echo $new password. We only need this temporarily in our script. We're not going to keep it here, but we're now prompting for our username, prompting for the password, but now we're echoing that password 1 back to the screen. So we are capturing the information, but we're just not choosing to display the information back to the operator. Now our script is getting near completion. We've just seen how we can use the read command and silence the normal output that it generates so that we can put in sensitive data such as passwords. With this ready, we're able to start to move on to the final part of the script where we can look at actually creating those mythical users. But in understanding our read command, we've seen then the option -p for our prompt, -s to silence the output, and looking at how we can move away from the default variable of $reply. And look at this, the finale. At last, we're getting to create those mythical users. But working through the script, we've been able to see different mechanisms that we're able to implement within Bash scripting to get the results that we want. We're now going to be looking at Sudo to elevate our privileges so that we're able to create our users, and looking at ways that we can configure the password. We've prompted for the password. We've got the password stored in a variable. Now we're going to see how we can use it. Come on, let's find that command line. So I do hope you're ready for this, the final fling, our finale. We can tidy up our little script for the moment. I'm just putting a space between the prompt password function and the user exists function. I don't need to echo out the new password. We were using that just for demonstration purposes, so let me remove that line. I'm also going to take out line 15 where we are setting the password variable because I don't need to set it here. Ideally, I set this once in the script and I only need to type the password once, so I don't want it inside of the function. I also, looking at the name user exists, this doesn't really work for us now. So I'm going to right click on this and choose refactor and rename, and I'm going to change this to create _ user. So refactoring the function name is going to change it in each location it is used, so both in the definition and in the usage statement. Again, we can see how the IDE is really working for us rather than working against us. As your script grows, it certainly is valuable having an IDE. And here, remember, we're just using PyCharm, but you could use Visual Studio Code or other tools, of course, are available. Back in my main block now, outside of my functions, I'm pasting in the new password. So this is where we're going to be prompting for the password, but storing it inside of our variable. This means I only need to set it once for each script execution, and I don't have to worry about setting it for each new user that is being set. As I go through now in my create user script or function, we can run the sudo and user add, so elevating our privileges. But the nice thing about this and using the script is I don't have to worry each time I use user add that we're setting the right options. So I can make sure they're set once and for all inside of the script. So the -s option is setting the default shell. The -m option is specifying that we do create the user home directories when we create the user. So we can ensure that the script runs correctly each time. Obviously, we need to pass our variable through, so $username. And that's created the user, but it won't have a password. So I'm going to echo out, but not to the screen. We're going to pipe this through to another command. So I can have user name and then colon. And then we can take the new _password variable. That was set in our main script, so it's going to be available to the function as well. And we're going to pipe it using the vertical bar to the input of sudo and passwd. With the password command, we take in the username and password, but we're not then having to prompt for the password in the same way as the passwd command. So this works really well for us. So we can see we've got our prompt password, we've got our create user function, the recently renamed function from our check user, and then we have our main block of code. Here we prompt for our password, and then worry about processing our arguments or reading in user inputs for our names. But now we are ready to see if this really does work. Are you ready? Then let's open up our command prompt. And with our command prompt open, we can go through and execute our script. If we execute it without arguments, note the prompt. We're being prompted now for a password. That was the first thing that we set. So that can be used whether we're processing arguments or prompting for the username, which we now see. We've created our user, and it should have the password set now. And you can see at no stage was that password echoed to the screen. If I use su minus and then the user account Fred, add in that same password that I entered when I created the user, I'm now changing through to that Fred account. I used a more secure password, so we didn't get any warnings about insecure passwords. But if you put a more simple password in, you'll see warnings. You'll see this if I exit out and then go through and run the script with arguments. So we can look at creating, say, user 1, user 2, user 3, and maybe even the root user. So, of course, we shouldn't be creating the user. We're being prompted for our password. I'll set a simple password now. But we can see then that we get those bad password warnings, but the password still will have been set. It just gives me the warning. Ordinary users can't set simple passwords, but the root user can. But take a look down the bottom. We check the user root. It is already there, so we don't create the user. So we've taken a look at bash scripting where we've seen variables and system variables like $1, $hash, and $at. We've seen the read command, the reply variable, and then using options such as functions.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.